He's the only person in India right now making these. But to a layman Foundry person watching this video, what exactly is a breaker core?
That is why you should always use ceramic breaker core in place of sand breaker. Software like Magma, they already have this provision.
Okay, so breaker core is recognized on a Magma software.
The fettler people call me up and say, sir, please call up our sir and tell him your breaker cores are finishing, for which we have taken a patent, by the way.
Okay, so you can't copy this. Welcome everybody back to the Foundry Podcast. Today we are here with a guest all the way from Nasik, Mr. UmeshJi. Welcome.
Thank you.
Mr. UmeshJi has brought himself from Nasik. He's also brought a lot of his, products. I think ceramic
breaker
cores. So Mr. Umesh has a very rich background in the foundry industry. He has about 40 years of experience, right? That's a lot. That's 4 times the experience I have. So I think if he has something to say, we should all probably listen. He has something that he's innovated. He also claims that he's the only person in India right now making these.
Right.
So that's a pretty big claim. That is something that's really interesting, which he's going to share with you today. You had this idea first in the UAE, and after that you brought your idea here to India. And now he's partnered up with a company called Om Metals, right? And that's why they've brought your idea to reality now, which is now commercially profitable in India. And again, I'm telling you this again, the only person in India making these, right? Tell us a little bit about the Gulf Foundry and your experience in the Gulf.
Well, I was working in India in Asian Foundry. I worked here for one of the reputed companies then.
Okay.
It was named Business Combine. I was working there for 15 years and I went to UAE as an expert in Asia. There they wanted to export some castings to Japan in Asia.
Okay.
But however, after going to Middle East, there was more demand for wear resistant casting, the casting which are used in crusher industries.
Okay.
So we had more requirement for wear resistant casting, and that's how I got into those casting or wear resistant castings.
Okay. So they brought you over there as an expert on SG iron.
Right.
And this is in what year?
This was 1995.
So you were making ductile iron in 95.
We were making ductile iron in 1970.
1970?
1975 onwards.
Okay, because I think ductile iron is something that only caught on here in the early 2000s, maybe 2010, 20. It's something
in India, they started making about 1965, they started making Asian castings.
So ductile iron was already common over here, you mean?
Correct.
Okay, great. So you move on as an expert to the Gulf.
Right.
You start with ductile iron, but then it turns out that ductile iron is not something that you're making very actively because of the construction.
There was more demand for other castings.
Got it. So fast forward, like the experience, how long were you in the UAE?
I was in UAE for about 20 years.
20 years?
20 years.
Okay. And which is how did you come across your breaker cores?
Well, those castings which we were making in UAE were mainly for wear resistance, mainly for crusher industries, cement industries, where there are 2 parts. One, those castings are highly brittle and they require what you can say, they are huge and their fettling time has to be very low.
Okay.
What really happens, the huge castings also require a lot of fettling time.
Right.
And to cut short that fettling time, we came across breaker cores.
In the UAE?
In UAE.
Okay.
And those breaker cores, although we were using over there.
Correct.
After I came back to India.
Correct.
I met Mr. Anil.
Right.
And with whom we started making the ceramic breaker cores for the first time in India.
Okay. So I have a few questions now. You're saying breaker cores, right? What exactly to the layman, like I'm a foundry person, I am mainly in the non-ferrous side of things. So we don't come across breaker cores very often. But to a layman foundry person watching this video, what exactly is a breaker core?
Breaker core is a part between the casting and the riser. What you really do is you put this breaker core on the casting. On the breaker core, you put a riser.
Okay.
Like this.
Okay.
You pour the metal. When the metal is solidified, you can hammer this riser out.
Okay. So it breaks off completely cleanly.
It breaks off completely.
Okay.
not only it breaks out complete, breaks out clean.
Right.
In
How do you ensure like the breakage will be completely uniform and always at the same line that you expect it to break at?
that you can see, we are providing a sharp edge
Okay.
between the casting and riser.
Correct.
You can see from here,
Right. It is pretty sharp.
this portion you can see is very sharp.
Correct.
So this makes sure that casting, the riser breaks
Only at that point.
at that point only,
Correct.
and not below the,
Correct.
not into the casting.
Correct.
So your casting is never rejected because of
Correct.
wrong breakage.
So I would think that the fact that these products exist means that fettling is a very strong problem for a lot of foundries.
Right.
Correct. So what foundries exactly have such a strong fettling problem where cutting is not possible? Why would they need a breaker core?
Now each metal has a different fettling difficulties.
Okay.
Now for example, stainless steel. Stainless steel is very difficult to fettle. If you have to remove riser, it takes a lot of time. You have to,
Why is that? Why only stainless steel?
because you can see the stainless steel has a very low carbon.
Okay.
Very low carbon, high chrome and nickel. So that casting you cannot gas cut.
Okay.
You cannot break. If you try to break, the riser will keep on bending, but it will never break. It has high
Got it.
ductility.
Got it.
So you can neither break nor gas cut.
Correct.
Because of very high chromium, it cannot gas cut.
Correct.
So you have to cut it only electrically by electric welding
Okay.
or gouging, you can say. That is not only expensive, and it makes the casting very dirty. It also, when you burn, when you
Correct.
cut it by welding,
Correct.
you are actually burning metal.
Correct.
In this case, so for stainless steel, if you use a breaker core,
Correct.
you can hammer it out.
Okay. You can just knock it off.
Right. And this is for stainless steel. But casting like high chrome or wear resistant steel, where it goes, the casting is very brittle. So if you break the casting wrongly, it will develop crack into the casting, and the
Okay.
casting will get rejected.
Right.
When we use a breaker core, you have to hammer it very lightly, so that no stress is developed in the casting and no crack. As a result, no crack is developed.
Okay.
So for high chrome or even manganese steel.
Correct.
So for various, this manganese steel is also steel which cannot be broken that easily.
Correct.
If you gas cut the riser, it develops cracks
Okay.
and they open up after heat treatment.
Got it. Got it. So,
So that
mainly,
is why,
mainly you develop this item for stainless steel, high
or
manganese
stainless
steel.
steel, manganese steel, high
Okay.
chrome, heat resistant steel, cast iron and HGI.
Okay.
It can be used, it can also be used for non-ferrous,
Correct.
but today we are more into ferrous casting.
What about cast iron?
Cast iron also, the casting, when the cast iron castings are very huge, say casting more than 1 ton, again riser removal becomes difficult.
Okay. So mainly bigger castings.
And because of very
okay.
high carbon and silicon, it doesn't gas cut easily. Many of those foundry people who are making cast iron, they are aware of this fact.
Correct.
So here with this breaker core, you can hammer those casting, hammer the riser,
Correct.
and remove it.
Got it. So those are your use cases for
Exactly.
breaker cores. Now I also have another question. Naturally, you mentioned that people have been making sand cores for like many years, right? Sand breaker cores. So why ceramic? Like,
Ceramic
what are
is
some USPs
because
ceramic? Like, what exactly did you learn in the
This-
Middle East that you came back and you decided to develop ceramic breaker cores?
Silica sand is under intense temperature
Correct.
and stress, because of which it fuses with the casting.
Okay.
And once the silica sand fuses with the casting, every foundry person is aware how difficult it is.
Okay.
Grinding becomes very difficult
Okay.
if the sand is fused. Now the ceramic sand has a high refractoriness, so it never fuses with the casting.
Got it.
That is why you should always use ceramic breaker cores in place of sand breaker
place
cores.
sand
Secondly,
breakers.
sand breaker core has another problem. It has a low strength, so you always have to make very thick. When you
Okay.
make a thick silica sand or breaker core, it reduces the efficiency of the riser. These ceramic breaker cores are very thin,
Okay.
so they don't absorb much of heat,
Right.
and as a result, it
doesn't affect
improves
the
the efficiency of the riser.
Okay. Not only it doesn't reduce it, but it improves the efficiency. is
Improves
what
the
you're saying.
efficiency of the riser.
Okay. So this is probably because if you're making a sand breaker core, what is your minimum diameter you can thickness you can go to?
Thickness there, usually you have to make a silica breaker core more than 10 mm thickness.
Okay, and these are hardly about 6, 7.
These are 6 mm, 5 mm, like
Okay,
that.
so they
Yeah.
can be much thinner.
In fact, there is a thumb rule for breaker cores. The thickness of the breaker core should not be more than 1/10 of the riser size.
Okay, got it.
Ours is 1/20th.
Okay, got it.
So
So that is why you
I
can
don't
always
know.
guarantee that it breaks off at that portion.
It not only breaks, it improves the
feeding.
efficiency of the riser.
The feeding. And I think also if people are worried, like maybe the diameter of your sleeve would probably be about 75 for this one.
No,
And
that
the-
what we have done in that, this while designing this breaker core,
Mhm.
the OD is made to suit the riser or the exothermic sleeves which we
Okay.
are going to use,
Okay.
and ID is made to suit the metal for which this riser is going to.
So this is also
breaker
something
core
that is calculated.
Yes, that is calculated.
Okay. So for
This
example now,
ID varies according to the metal.
so these calculations you do before you maybe like you select the breaker code.
Yeah,
that a
over
person
the
would use?
years we have experience.
Okay.
So what we do when we go to a foundry and what metal they are making, we suggest our own size.
Okay.
Also, if foundry want to have their own size,
Mhm.
we can supply them in that size also.
So that's not a problem. MOQ.
That is not a problem.
MOQ is not an issue.
Right.
Okay.
In fact, some parties and some foundries want
Right.
their own opening. We provide them.
Correct.
Or else, we suggest them our opening sizes, or which they can conduct trials.
Correct.
And once they are successful, they can go for these breakers.
Correct. That's good. Now, two questions, right? Many foundries today are using simulation, right? So, is your product capable of being fed into a simulation software?
Yes. Software like Magma, they already have this provision.
Okay, so breaker core is recognized on a Magma software. Is what
On
you're saying.
Magma software, it is recognized.
Okay.
And if you give them the breaker core size, they can do the simulation along with the breaker core for their customers.
Okay, that means it's already trial and test for
Yes,
them to have
yes.
incorporated into their software.
It is incorporated in their
Amazing.
software.
Do you know if in any other softwares that have incorporated breaker cores?
Well, I do not know so many softwares, but Magma is a well-known, world-renowned
Correct.
software.
You know of Magma at least.
Yeah.
There may be others, but you're not
Correct,
aware of them.
correct.
So I think that's something that we'll dig upon.
That's
The fact that Magma has taken the time and attention to actually put this into their software means that it is a proven technology. Other than that, it also
In
means
fact, we had gone to one of these GIFA exhibitions
that, okay,
where,
in Germany,
no, that was in Thailand,
in Thailand,
where last year,
Right.
where actually Magma was showing it. They had on their stall.
they were displaying it as a
They are
capability in
displaying of the
Okay.
after by putting breaker core.
their. So that also means that a lot of customers have come to Magma and said, "Hey, your software is good, but it
Yes,
doesn't
yes,
allow me to
yes.
put my breaker cores in it."
Right.
That's amazing. So that's something I
They
never
were
knew about.
they had put this on their stall.
Right. Correct. So now I don't think we need any more validation as to why breaker cores are needed because the fact that, okay, that's one thing. Now, today, a lot of people are worried about sand reclamation, right? So now, if
Right.
you're replacing sand breaker cores with ceramic, does it as easily go into your
Yes,
reclamation
in
process?
fact, that is the advantage of this.
Okay.
This does not mix with the sand,
Okay.
and it will break into few pieces,
Correct.
which are caught in that
In your sieving
sieve.
process.
Yeah.
Right. You're shaking.
So
and
it
knockout
doesn't go
process.
into the system.
Okay.
It gets removed very easily.
Got
It does not spoil the sand
So
system.
what do I do with all the ceramic that remains after my sieving is done and maybe the hot green sand?
that goes as a waste.
So, okay, is there something that maybe you have in the pipeline in the future that maybe you could buy the ceramic back,
I mean,
reuse it?
if that large volume, if
Correct.
we can collect, then
Correct.
naturally it can be recycled.
So that is
At one time, even sand was not recycled.
correct.
Today we recycle the
So
sand.
that is an opportunity for future business for you.
Exactly.
That's good. So collect your ceramic. It may be bought for money in the future.
Right.
Can you give us any real world examples from successful implementations, like maybe customers that you worked with in the past who have come up and said, okay, like I need ceramic breaker cores, and then maybe they have been very successful. Like any examples?
There are companies which are not making casting without breaker core.
Okay, so it's like 100%. Every box needs to have a breaker core.
I mean, once they get used to it, they know the advantage of using breaker core.
Correct.
So they never design their methading is not without breaker core. It is always with breaker core.
That's good. That's good. So thank you, UmeshJi. I think you've covered a lot about breaker cores and this new technology. Thank you for coming all the way from Nasik. And thank you. So guys, welcome back. We now have Anil. Anil is the person who actually took UmeshJi's idea and made a product out of it. So we already heard from UmeshJi a lot about why breaker cores are needed, what breaker cores are, and why they have developed them in ceramic, right? So Anil, you'd like to share a lot of stuff about, when UmeshJi approached you 6-7 years back, right?
6-7 years, yeah.
How did he convince you exactly? Like, hey, you were a scrap dealer at that time, right? You're still actively in
We
scrap.
are still actively into scrap.
In fact, your company was also Om Metals and Alloys.
We changed the name
changed
from
the
Om
name
Metals and Alloys to
to
Om Metals and Techno Ceramics.
So you believed in the idea so thoroughly that you renamed your entire company to reflect your new product.
Yes, definitely.
Right? So what exactly sold you on the idea? Like, how did you get started? Why did you trust UmeshJi? Why did you develop this? And give us an idea of how that process went.
We just started into ceramics.
Okay.
And I met UmeshJi as a consultant.
Okay.
And with his background, and he said, I have a requirement of ceramic breaker cores. You design these for me.
Okay.
So we started there, and because it was a new product, new products always interest me. Innovations always interest me. I said, okay, let's get into it. Let's see what happens.
Right.
And we did, and we've been innovating since.
Right. And has been
and
successful.
Fortunately, we've got a very good response.
Right.
So, from the SG industry, stainless steel industry, manganese steel, high chrome, wear resistant, HRCS, we've got a good response throughout. Even from the aluminum industry.
Okay.
In the non-ferrous, but to a very limited extent.
Right. I think non-ferrous is something you're working on currently.
We're still working on,
right,
yes.
Right. But stainless steel, manganese steel, all those
these are all proven now.
Okay. So
it's gone step by step, but it's proven now.
Okay.
And fortunately, we've met a lot of people along the way who were willing to take trials, and they've succeeded.
How has that process been, like getting a foundry to accept that maybe they need breaker cores, the development part? What is that process like?
Well, first of all, the viability, commercial viability has to be taken into account. Any foundry would have to do that.
Right.
And then the technical viability. Or rather, I would like to say that if the commercial viability is there, then the technical viability has to be proven.
Okay.
Because you want a sound casting. You cannot afford to have a bad casting.
Correct.
So, first I have to prove to the technical department that yes, you're going to get a sound casting.
Correct.
And then I have to prove to the commercial department how they're going to gain from it.
Right.
If they're going to buy a breaker core worth X from me, they're going to get at least 2x profit out of it.
Right.
So that's the only way. It's a win-win situation for everyone.
Right. Right.
And that has been working because you save a lot of time. Time in the sense the production time. You can pour a casting, but by the time you fettle it, the casting is just lying in your factory for 7 days, 10 days before you finish fettling and throw it out.
So it's money tied up.
So it's money tied up.
Right.
So, and that money, even if you take the interest and turnover and rollover.
And the area to store it.
The area to store it.
Right.
I mean, I go into foundries where I have actually seen you go into a foundry. I've gone into a foundry where they had heaps of castings piled up.
Is that something you look for now?
I look for it, definitely.
So if you let Mr. Anil into your foundry, his eyes are going to be on the heap, on the mountain of castings.
Of fettling, casting to be fettled. Because I know I can get that cleared.
Right. Right.
And initially it's a problem because you have to convince the production people. But then once everybody is in line, they all realize how smooth it is going for them.
Right.
I've had the fettler people call me up and say, sir, please call up our sir and tell him your breaker codes are finishing.
Okay.
Because they want their job is easier.
Right. So I would assume that probably the person that you look for, you source out in a foundry would be the fettling department.
Fettling department is exactly right.
Right. As soon as you come
He
to the
has
door,
see the guy who
Right.
melts the metal and pours it.
he has
His
nothing
job
to do
is
with
done.
it. He has nothing to do with it. Right.
All the pressure comes on the fettling department.
Correct.
Why isn't my casting out?
Right.
I gave it to you a week back.
Right.
So that is the guy whom I really look forward to talking to.
Right.
Production fettling.
Right.
And then, of course, management has to approve
Right.
new trials and
Because you want to get paid for them.
otherwise it doesn't make sense.
Right. That's good. Anil, I'm having an amazing time with you. Thank you for being here.
Yeah, thanks.
So, anything else that you would like to talk about? I think you mentioned about, since you've been actively dealing in scrap, right? You said you imported scrap a while ago and you used to see that people abroad were using breaker coils,
Yeah,
right?
a lot of the manganese steel scrap that is being imported,
Correct.
and if you look carefully enough, you will see the breaker core designs
Okay.
which allow you to have a zero fettling. It's just basically on the fitment side where they don't want any finish or anything. They just have a riser. In fact, we've developed that. If you notice, this particular breaker core cuts below the surface.
Okay.
It's just 2 mm below the surface.
So, this would be used on an area which is not unmachined anyway.
Unmachined anyway. It
Right.
goes as is.
So, there's no grinding to be done as it is.
Nothing to be done. Just knock it
Absolutely.
off and throw it out.
Okay. Amazing. So, this is something you all have developed recently.
Yeah, we've developed this after looking
Okay.
at manganese steel.
So this idea you have got from a lot of import of scrap and something, and you also said that people abroad are using breaker coils very regularly. So why is India
A lot.
not
Exactly.
catching up?
Because we have been using sand breaker cores, which have their own limitations.
Right,
The V notch doesn't remain the same.
right,
The resin in the sand creates gases when heated to that extent.
right.
So all those issues are there.
Right.
This material is totally inert.
Okay.
I mean, I couldn't produce any gas out of this if I wanted. If I could
It's
heat
also
it.
insulating to an extent.
It's insulating to an
Right.
extent, but it's very minimal
Right,
because we have kept the thinness. It's as thin as possible.
right,
So it doesn't absorb much heat. In
Right.
fact, whatever it absorbs, it gives back into the riser.
okay,
And because of these special meshes that we've created, for which we have taken a patent, by the way.
okay. So you can't copy this. if in case if in case your competition is watching out,
Yeah, well.
you already cleared that. That's good.
So different designs, different materials, different metals. Then we
Amazing.
also have something called side. These are all for top risers.
Right, right.
Then we have something for the side breakers.
Okay. So these are the different types of variety that
This is
you
a variety of breaker cores that I'm
Yes.
showing you.
Right.
These are for the side breaker cores
Okay.
where you have a in-gate feeding from the side.
These also have that clean knockoff, right?
Yeah, they also have a clean knockoff, or they have. See, this design can be changed.
Right, right. So
And
it
then
looks like
even that one that you have there is for a different design.
Yeah, this is a little different. Tell us about the star shaped.
It just gives you more points to break off.
Okay.
More
it.
than a circle, we need points.
Right.
The more fractures you create, it's easier to break off.
Correct. So these are all like work in progress.
Yeah, and it is going to be work in progress for a long time.
So I see you guys have taken this ceramic breaker opportunity very seriously. You guys are actively developing up a lot of a lot of variations, trying a lot of things. So who knows where you all
For
will be.
example, I'll just tell you, this is one of the smallest breaker cores we have,
Okay.
a 15 mm only.
Right.
But this is for a 1 inch, and this goes for HRCS trays. The heat treatment trays that you see,
Correct.
they require a lot of risers. For them, you need these small breaker cores.
Then you can just break all of them off.
You break off them, you don't even need to grind them. They're
Okay.
being just broken and sold as is.
Wow. Amazing.
So the person who's doing this, I went to his factory, I wanted to take a few videos. He says, sorry, you've come at the wrong time, you've come at 12 o'clock. By 10 o'clock, all my fiddling is done.
That's not that's not something he had earlier, right? He couldn't say that earlier.
No, he couldn't say that earlier. That's why he approached us. So
Okay,
there are a few instances like that.
So anyway, thank you, Anil. Appreciate you coming on the podcast. You also do something with refractory, right? I saw that on your website.
Yeah, we do manufacture investment casting cups.
Okay.
Cups for ceramic cups for investment
Okay.
casting.
Okay.
Those are also one-time use.
Okay. Correct. So that's how you got the base of how you should work with ceramics.
Yeah, but though that material is different, this material is different.
Okay.
The materials are
Completely different.
completely different.
Right. Is there anything else you would like to add?
Not much, but costing, it is definitely viable once you give it a month or so at least.
Right. It needs some perseverance. as you
It needs
mentioned.
some perseverance
Right.
to get things right.
Right.
And once you get things right, it can work.
Right. And then you also said that companies who have actually persevered with the development, they are never not leaving you, right?
They're
They
not leaving
constantly-
us, and
Right.
they've increased their production in their existing capacity.
Right.
They will increase their production.
Right.
So what more can you want?
Correct.
The easiest way to increase production.
So that's good. I mean, on the Foundry Podcast, we are all about having new technologies. People like yourself coming up with new innovations, talking about something that maybe people have heard of, but a different twist, a new type of as you've changed from sand to ceramic. That's something absolutely new. To be mentioned, you can also find his entire product range on the Foundry Shop now, right?
Yeah,
I'll
definitely.
put the banner here. He is registered on the Foundry Shop. Thank you so much.
Thank you.
Appreciate the support.
Thanks so much.
And thank you guys. Thank you guys for watching.
Thanks a lot.
Do check out Anil's. We put your website in the description.
Yeah, the
Right?
website's there.
Where else are you available? Email, LinkedIn,
Everywhere.
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 So we'll put all the links in the description below, and you can check out Om Metals and Techno Ceramics.
It's omemetals.com.
Ommetals.com. Okay.
We have not changed the Gmail as
the
yet.
domain, right?
The domain name as yet.
That's good. So anyway, thank you for getting UmeshJi along. He managed to explain a lot of the technicals to us, and in a way that the practicality would make sense. And
Right.
you have managed to cover things from more of a commercial type, more of why the product was needed and how you went about developing it.
Yes, definitely.
So thank you guys. See you on the next episode.
Thank you.
Thank you.
Bye.
Thank you.
Thanks.